Hello everyone. I know it's getting close to lunchtime, but stick with me for a bit longer. Yeah. I'm Hiroki Matsukuma. I work as a manager of the reverse engineering team at Cyber Defense Institute, Inc., a Japanese cyber security company. I used to get my hands dirty with expert development for supporting security assessments and penetration testing. I often enjoy taking part in CTF competitions as a member of a Cyber Dark Inferno team on weekends whenever both my family and my schedule allow. My favorite CTF category is Palm, and I was so passionate about it in the past that I developed a heap exploitation technique targeting glibc called House of Behavior. But today, instead of focusing on binary exploitation, I'd like to talk about PHP Object Injection technique I came up with some time back. So, introduction. I'll begin by introducing object serialization, followed by insecure deserialization, and then briefly touch on PHP Object Injection and its mitigation. Now, serialization. Now, developers frequently deal with storing and restoring data or transferring it across networks. In these situations, objects and data structures must be transformed into a format that's suitable for treating as byte sequences or strings. And this process is called serialization. There was serialization methods that are independent of a programming language, but each programming language and library offers its own native serialization method. For instance, Python has Peco, Ruby has Marshall, and PHP provides the built-in functions serialize and unserialize. Serialization is a crucial aspect of programming, but developers need to be careful when using it. Deserializing user-supplied data without proper validation can give attackers the chance to compromise the system. Such issue is known as insecure deserialization or deserialization untrusted data, which is recognized as significant vulnerability in web app development field and has been included in the OWASP Top 10 in both 2017 and 2021. PHP Object Injection, or POI for short, is an attack that falls under insecure deserialization in PHP. In POI, a technique called properly oriented programming, or POP for short, is often used, which abuses multiple objects to perform actions like file operation, information gathering, or even code execution. Many security researchers have developed gadget chains, and PHP library maintainers have also worked to reduce their impact. Some frameworks and libraries added an safeguard to risky classes by overriding their wake-up method. I'll go the details of that later, but this approach was easy for the developers to implement and also effective as a mitigation. Wakeup can be bypassed by exploiting implementation bugs in PHP, and this has been discussed in the PHP project's GitHub issues. However, since Wakeup is not a security feature, so PHP maintainers do not consider bypassing it security issues. Some related bugs remain unresolved. That said, implementation bugs may eventually be eliminated with the efforts of the PHP community. So today, I will share a simple technique to bypass Wakeup based on PHP's design. So this talk will proceed in the following order. First, I will start with PHP Object Injection Primer, where I will lay out the foundation concepts related to POI that will be referenced throughout the presentation. Next, POP gadget reduction by Wakeup override. I'll explain the mitigation strategy of overriding the Wakeup method to reduce POI risks. I will also show how widely this has been adopted in various PHP packages by presenting real-world examples. Moving on in bypassing Wakeup using arbitrary object instantiation gadget, I'll introduce the technique I'm proposing and explain the related non-vulnerability called arbitrary object instantiation that enables this bypass. And maybe this is spoiler for CTF players. During demo, I apply this technique to the Neos Flow web framework and bring Guzzle RCE1 from PHPGGC back to life. I'll also explain the flow of the gadget chain used in the demo as much as time allows. Lastly, we'll wrap up with future works and the key takeaways. Now starts. PHP Object Injection Primer, but before, let's quickly go over some important things about PHP objects that will come up later. Like in many other object-oriented programming languages, PHP objects are instantiated from classes and they are destroyed when no references are left or when the interpreter shuts down. Developers can change the behavior of objects, setting creation and destruction. Yeah, construct and destruct by overriding the magic method construct and destruct. Also, class properties can have visibility setting. These private, protected, public, and since PHP 7.4, type declaration are supported, like this, bool, float, string, object. So, and As I mentioned earlier, the serialize function is used for object serialization. For instance, as shown in the snippet, serializing an object of class, class foo produces byte sequences like this. Here, at first glance, it may appear to be just a string, but if you look closely, you notice that some properties contain null byte, like this, in their names due to their visibility. This can be pitfall when testing unserialization on the command line, so be cautious. And then it's time to talk about POI, PHP Object Injection Primer. Now first, simple PHP Object Injection. In POI attacks, modifying the serialized data can alter object properties, which may affect the program behavior after unserialize. For example, with an object like this modifying property, balance, and to larger number could increase the account balance. Is this all you need to know for the attack? No, this is just an event confined to the scope of application logic. And as I mentioned in the introduction, POI can lead to far more serious consequences. The next, property-oriented programming. These powerful attacks are carried out using a technique known as property-oriented programming, or POP for short, which works similarly to code wheels attacks. In POP, not only the associated code flow of a class, but also its properties are exploited. The exploited classes are called gadgets, following the terminology used in other code wheels attacks. Similar to those attacks, POP can utilize a gadget chain, which combines multiple gadgets to perform arbitrary operation. Next, chaining gadgets. In this talk, I will classify the gadgets in POP into 3 categories to make the explanation easier. The first gadget type is the one that starts the gadget chain, often exploiting magic method called during or after unserialize. For example, destruct is called when the object is destroyed. Wakeup is called early in unserialize. And toString is triggered when the object is treated as a string. Other methods tied to predefined interfaces might also be used. Yeah, like this, iterator current array access offset get. These methods access properties, and that's what kicks off the next gadgets in the chain. And the second type is gadgets that act as intermediaries, bridging from the initial gadget to the target gadget. that I will discuss later, PHP's loose handling of types allows these intermediary gadgets to execute without errors as long as they possess the necessary properties and methods for the next step in the execution flow. As a result, as long as the property types are not explicitly defined, the combination of intermediary gadgets can be quite flexible. That said, it's generally better to use gadgets from lesser amount of products to make the gadget chain more universal. Then the last type is The last type is responsible for achieving the goal of gadget chain, such as reading, writing, and deleting files, executing PHP info, or running arbitrary code and OS commands. Typically, the goal would be to achieve remote code execution, but when there aren't enough gadgets available, we might have to take some additional steps for running the arbitrary code, such as writing our code out to the storage and then loading it by include. In penetration testing or CTF competitions, it's often required to combine these gadgets into a gadget chain. However, in time-limited scenarios, building a gadget chain from ground up can be challenging. In these situations, I recommend using PHPGGC framework. It includes gadget chains found in popular PHP products. And as long as the necessary conditions for the chain are in place, achieving the goal becomes much easier. Next, pop gadget reduction by Wakeup override. Before we dive into the main topic, let's briefly touch on recommendations in PHP manual regarding POI mitigation. In the warning under the unserialized function, it suggests using a safe standard interchange data format like JSON when there is need to pass serialization data to users. If there is a requirement to use PHP serialization format in user-facing areas, it's recommended to ensure the data has not been tampered with by verifying it with HMark. However, this is just a warning for developers using unserialized function. Even if developers verify serialized data with HMark, there's still a risk of POI if the secret gets leaked. That's why some libraries and frameworks have taken it upon themselves to implement POI mitigation. The approach of overriding Wakeup was specifically designed to disable POP gadgets, and we can see it implemented in the following PHP packages. guzzlehttp PSR7's Guzzle PSR7 FN stream, According to comments in the pull request, the additional of the safeguard was triggered by its use in the POC for CVE-2019-6340, a remote code execution vulnerability in Drupal. Unfortunately, it seems to have also been used in the POC for CVE-2019-6340. And Symfony process, WordPress, eSoft E2. According to comments in the code, the safeguard was added after CVE 2020-15148 was discovered. Now we will review the mitigation in place by walking through the gadget chain. Yeah, this is. Let's take a look into the class Guzzle PSL7 FN string from an earlier version of Guzzle HTTP PSL7 before the mitigation was added, and also the gadget chain Guzzle RCE1 that uses it. The implementation used to look like this. This gadget chain takes a function name and parameter as argument. It then creates an array that consists of a Guzzle HTTP handler stack object instantiated with the given arguments and string resolve, this one. The array is stored under the key clause in another array, which is eventually passed to Guzzle HTTP PSL7 FN string. So next, the gadget Guzzle HTTP PSL7 FN string takes methods as an argument in its constructor, assigns it to the method's property here, and iterates over methods to set function names to properties prefixed with fn. In execution flow of the gadget chain, it plays a role in invoking an arbitrary objects method via the destruct, this call use func, and function and the fn clause property. To summarize, this gadget can be used on its own to invoke arbitrary functions, since it uses call user func to call functions. Its role in the gadget chain is to invoke arbitrary methods on arbitrary objects. If certain conditions in the code flow are met, we can use the gadget Guzzle HTTP handler stack to call any function with a single argument. Here. Oops, sorry. As a result, by chaining these gadgets, it's possible to invoke arbitrary function with a single argument, starting from the destruct method of the Guzzle TTP PSR7 FN stream gadget. This could, for instance, allow executing arbitrary commands with the system function. On the other hand, the current Guzzle HTTP PSR7 FN stream overrides the Wakeup method. Yeah, like this. What does this imply? The answer is quite simple. Let's follow the flow of how unserialized handles gadget chain, including Guzzle PSR7 FN stream. First, the unserialized function begins processing the gadget chain, which includes Guzzle PSR7 FN stream. Inside unserialized, the Wakeup method of Guzzle FN stream is invoked. The gadget chain execution is interpreted by the exception thrown by Wakeup, this logic exception. So simply overriding Wakeup with a small trick makes Guzzle RCE1 no longer usable as a gadget chain. For library developers, this solution is both simple and effective, as it can be quickly implemented for any class that doesn't require serialization. However, for those trying to build gadget chains, it's a significant challenge since it limits the number of usable gadgets. Next, bypassing Wakeup using arbitrary object instantiation gadget. So, before discussing the technique, I will first provide an overview of arbitrary object instantiation. Arbitrary object instantiation, or AOI for short, is a vulnerability that allows the creation of objects from arbitrary classes. This piece of source code corresponds to CVE-2019-6340 in GLPI. Both AOI and insecure deserialization share common characteristics. They enable the creation of unintended objects by the developer. The concept behind the proposed Wakeup bypass technique is straightforward. The idea is that Wakeup protection is only relevant when using unserialized. So if an object can be instantiated directly, the restriction no longer applies. And this approach works as long as there exists a gadget that allows arbitrary object injection. AOI vulnerabilities are typically found in areas where users can specify class names, so developers have likely already minimized such risks by paying extra attention to those parts. However, AOI gadgets can lurk in code paths that users don't normally interact with. So, and now it's time for the demo. In this demo, I'll demonstrate a POI attack by leveraging a gadget chain that includes both Guzzle PSR7 FN stream and a certain AOI gadget. against a Nails flow application vulnerable to insecure deserialization. And what is Flow, Nails Flow? Flow is a PHP web application framework focused on domain-driven design and clean code based on strong conventions and best practices. It allows you to rapidly create powerful web applications created with love by the Nails project. Someone in this room knows Nails CMS. This framework is for the Nails CMS. So the tools and the PHP package versions used in the demo are as follows. Among them, doctrine overwhelm may appear outdated since version 3.3.2 is the latest release, while version 2.20.1 was used here. However, this is simply because Nails Flow version 8.3.13 depends on that specific version, so please bear with it. So, changing the machine, wait for a while. Yes, this is a vulnerable. This is an application vulnerable to insecure deserialization, and this is the payload. I implemented the gadget chain with PHPGGC, and I named the gadget chain Flow RCE1. And the payload is system touch temp pound. It creates the file named temp pound. This is a payload generated by the gadget chain. And copying it. And this is the vulnerable application. For demonstration, this serialized data and unserialize it, and string representation and the source code. So if here change to demo string representation demo, and and the payload resend and edit and send. Edit and resend. Change the payload by this functionality. this is the parameters, and this is this SIR S5 demo. This is the original serialized data, and we replace it with the payload. And before this, we should check the file temp pound does not exist. The application is running on Docker, so the app is service name, and ls-l temp. No pound, just peer. And send 200 OK, 200, and the pound. Thank you. Yeah, thank you. And next, I will explain the payload gadget chain, how gadget chain works. Wait a while. Okay. And so the gadget chain overview. Let's take a look into the class Guzzle PSR7 FN Turin from an earlier version. Sorry. I need a text. I need a script, sorry. Wait for a while. Detailed POC analysis. Next, let's dive into a detailed explanation of the gadget chain. As you can see, the gadget chain is composed of the following gadgets. Nails flow, resource management, publishing, message collection, doctrine ORM, query, tree walker chain iterator, and same as the Guzzle RCE1. Yeah, it's the initial gadget. The gadget starts from the nails flow, resource management, publishing, message collector. Its flash method iterates over the messages using a for each loop, and the gadget chain can include the use of methods available to the iterator. Then, doctrine ORM query, tree walker chain iterator serves as the AOI gadget. It allows the creation of arbitrary objects by passing any tree arguments to the constructor. Here is it. In the gadget chain, the first argument is a string, Guzzle http PSR7 FN string, the string. While the second argument is an array where the key is close. This part is the same as Guzzle RCE1. And the remaining steps follow the same logic area. And any function can be called with any single argument. In the demo, the function system was called with the argument touch 10 pound. Yeah, this it's over. And the remaining part is the, almost the same as Guzzle RCE1, but I passed the class name fn stream as string, so there is no need to declare the class in PHPGGC. So commented. Yeah. And the last section, as for future directions, the following aspects can be considered. Support for the upcoming Nails Flow 9.x. Unfortunately, one of the gadgets used in the demo, the EAOI gadget, Doctrine, Overwhelming Query, Tree Walker, Chain Iterator, has been removed in the latest version of Doctrine Overwhelm. As Nails Flow 9.x approaches its release, other AOI gadgets will likely be needed. So the version was 8.3.13 is using the older version of Doctrine ORM. So the demo was succeeded. And contribution to PHPGGC, improvements to existing gadget chains that were disabled due to the Wakeup override, as well as the introduction of new gadget chain utilizing the technique, are expected. Key takeaways. For CTFers and penetration testers, there may be promising pop gadgets within the target that throw exceptions in Wakeup, but with AOI gadgets, it is possible to build a gadget chain that bypasses Wakeup. For developers, as stated in the PHP manual, if serialized data is exposed to users, it is recommended to use a safer way, like JSON, instead of PHP native serialization method. Additionally, even if a library has taken measures against POI, do not complaints always validate data using standard methods. And it's over. Any question? Thank you.